Hi everyone! Today we're going to see sample problems for the topic Fourier series of arbitrary period 2L. Example 1. Obtain the Fourier series of the function f of x equals L minus x for x is between 0 to L, and f of x equals 0 for x is between L and 2L. First, let us write the formula for the Fourier series expansion. Our goal here is to solve for the coefficients a sub 0, a sub n, and b sub n. Let's begin with a sub 0, and this is the formula. Our function here is a piecewise function, so we expect two integrals. A sub 0 equals 1 over L times the quantity definite integral from 0 to L. f of x is L minus x, then dx, plus the definite integral from L up to 2L, the function 0, then dx. Because this is 0, we will cancel this out. We will now find the a sub 0 based on the first integral. The integral now is Lx for L minus integral of x is now x squared over 2. Then we evaluate this with respect to limits from 0 to L. Then we have like this. The first group here is the evaluation of the function with respect to L, minus this group here is the evaluation of this function with respect to 0. Look at the second group. Because of the 0, we can cancel it out. Let us simplify the first group. We factor out the common L. And we can cancel the L here and the L in the denominator. Then we simplify L minus L over 2, and we have L over 2 as the value of a sub 0. Let us copy the value opposite a sub 0. Then let's have a sub n. We have this formula. Considering the given, we have now a sub n is equal to this function. Because of the 0 of the second integral, we can cancel it out. Then let us evaluate the value of a sub n based on this first integral. When we solve for a sub n, we're going to use the Bernoulli's formula, and we write it here. So we collect for the u and the dv. U is the L minus x, and the dv is the cosine n pi x all over L, then dx. For the function u, we will differentiate until it reaches 0. U prime is equal to negative 1, and u double prime equals 0, then we stop. For this dv, we will integrate the function. Integral of dv is now v equals integral of cosine n pi x over L dx is L over n pi times sine of n pi x over L. The integral of v is now v sub 1. This is equal to negative L squared all over n squared pi squared times cosine n pi x over L. Now let us substitute the values in the Bernoulli's formula. We have this 1 over L times the quantity. This pair of factors is the uv, minus the second pair of factors. This is u prime times v sub 1. Then later, we will evaluate this with respect to the limits from 0 to L. So we have now these two big groups. Let us now simplify some terms. Look at this L minus L. It becomes 0. So this pair of factors becomes 0. Also, look at this sign of n pi times 0. This is now 0 over L, so this is now sine of 0, and this will make the whole pair of factors to be 0. So let us copy the remaining terms down here. We can simplify further by cancelling this L in the denominator and the L square in the numerator here, respectively. So the resulting equation is now negative of L over n square pi square times cosine n pi plus L over n square pi square. Then we remember that cosine nx is equal to the negative 1 that is raised to power n. We will substitute it here. And this is now the resulting equation. From here, let us factor out a common factor, and that is the L over n square pi square times the quantity 1 minus the negative 1 that is raised to power n. Analyzing this, we can see that a sub n is equal to 2L over n square pi square when n is odd. Also, a sub n equals 0 when n is even. We're going to use this value of a sub n. We will write it here, but we will take note that this is the value of a sub n when n is odd. Next, we have the b sub n, and this is the formula. Considering the given function here, we have the value of b sub n just like this. We have the two integrals considering the piecewise function. Look at the second integral. Because of 0, we will cancel it out. We will just solve the value of b sub n based on the first integral. Of course, we will use the Bernoulli's formula. We write again the u and the dv respectively. We know what to do for the u. That is, we differentiate until it reaches 0. So we have u prime equals negative 1, u double prime equals 0. Then we stop. For the dv, we will integrate continuously until this level. Integral of dv is v equals the negative L over n pi times cosine n pi over L, then x. Integral of v is v sub 1 equals the negative L square over n square pi square times sine n pi over L times x. Now let us use the Bernoulli's formula. It becomes like this. We have the 1 over L times this pair of factors is the u times v minus the second pair of factors. This is the u prime times v sub 1. We evaluate this with respect to the limits from 0 to L. So we have the two groups here. Let us simplify some of the terms. First, we have this L minus L, and this becomes 0, meaning this pair of factors will be cancelled out. Look at the expression in here. We have L and L that we can cancel, meaning we have now the sine n pi. But we know the value of sine n pi, and that is 0. Because of that, this whole expression becomes 0. What about the sine of 0 multiplied by the fraction? This is now sine of 0, and the sine of 0 is simply 0, meaning we will cancel also this expression here, which means we need to simplify only this part. And we copy this remaining term down here. We have now this negative 1 over L times L times the negative of L over n pi. We can see that we can cancel this L in the denominator with the L here. Simplifying further, negative and negative becomes positive, L over n pi. This is the value of our b sub n. Let us copy this value opposite the b sub n. We will now substitute the coefficient values in the Fourier series expansion. So it becomes like this. The a sub 0 becomes L over 2. The a sub n is now here, and the b sub n is given here. Please remember that in our a sub n, we said this is the value of a sub n when n is odd. To satisfy that, we're going to distribute the summation symbol to each of the terms inside. So it becomes like this. But with regard to our a sub n, since we say that this is only true when n is odd, we will write it here that n is equal to 1, 3, 5, and so on up to infinity. While this complex fraction is simplified into L over 4. We can simplify further by moving the constant terms in front of the summation symbol. For the first summation here, the constant is 2L over pi square, and what remains here is 1 over n square. For the second summation, the constant is the L over pi. What remains here is the 1 over n. This is now the final answer. Example 2. Obtain the Fourier series of the function f of x equals pi x for x is between 0 and 1. f of x equals 0 for x is between 1 and 2. Let us write the Fourier series expansion formula. This is the formula for the interval from 0 up to 2L. In our problem here, the interval is from 0 up to 2. Therefore, we can say that 2L is equal to 2, then we can solve for L. L is equal to 1. Then we can rewrite our f of x. We will change the value of L as 1, and we can simplify further our f of x formula, and it becomes like this. Let us now solve for the coefficients a sub 0, a sub n, and b sub n. Let's begin with a sub 0 equals, this is the formula. Let us now write the value of a sub 0 with respect to our piecewise function given. That is why a sub 0 equals 1 over 1 times the definite integral from 0 to 1 of the function pi x, then dx, plus 1 over 1 times the definite integral from 1 to 2 of the function 0, then dx. Because the function 0 is here, we can cancel this out. It means we will solve for the value of a sub 0 based on the first integral only. 1 over 1 is simply 1. We can remove this, and we can put the constant pi outside the integral symbol. Then we do integration. The integral of x is x squared over 2. Then we evaluate this with respect to limits from 0 to 1. It becomes like this. 1 squared over 2 minus 0 squared over 2. We can cancel this 0 squared over 2. We simplify 1 squared to be 1 over 2 times pi. So we have this pi over 2. This is the value of a sub 0. Let us write the value down here. Then we go for a sub n. This is our formula. Since our L is equal to 1, we can simplify a sub n formula into like this. Then let us write the corresponding value of a sub n with respect to our piecewise function. We have two integrals here. The 0 function in the second integral will cancel the second integral. Remember that we're going to use the Bernoulli's formula, and here it is. We will choose for the u and the dv. U is the pi x, the dv is the cosine n pi x dx. For the u, we will do differentiation until it reaches 0. So u prime equals pi, u double prime equals 0. Then we stopped. For the dv, we will integrate. Integral of dv is now v equals integral of cosine n pi x dx is 1 over n pi times sine n pi x. The integral of v is v sub 1 equals negative 1 over n square pi square cosine of n pi x. Then we will substitute the corresponding values in our Bernoulli's formula. So a sub n is equal to this pair of factors is the uv minus the second pair of factors is the u prime times v sub 1. Then we will evaluate this with respect to limits from 0 to 1. Then we have the two big groups. Let's simplify some of the terms. The sine n pi will give 0. Later, we will cancel this group. The sine n pi times 0 will give us sine 0. And the sine 0 is simply 0. This group is also cancelled. Then we write the remaining terms. And we have like this. For the cosine n pi, it becomes this negative 1 that is raised to power n. And this cosine of n pi times 0 is cosine 0. Cosine 0 is 1, and that means we will just copy this part of the group, and we write it here. That is negative pi over n square pi square. From here, let us factor out the common, and that is the pi over n square pi square. What remains in the groups are negative 1 that is raised to power n minus 1. We can cancel this pi in the numerator, and there is a pi square in the denominator. So the final answer is 1 over n square pi, and this negative 1 raised to power n minus 1. When we analyze this, we can see that a sub n equals negative 2 over n square times pi when n is odd. A sub n equals 0 when n is even. We're going to copy this value of a sub n, but we take note that this is the value when n is odd. Then we proceed to b sub n. This is our formula. We learned that L is equal to 1, so we can simplify our formula into like this. Then let us write b sub n value with respect to our piecewise function. It becomes like this. We have two integrals. For the second integral, because of the function 0, we can cancel this out. Then we will solve the first integral for the value of b sub n. Again, we will use the Bernoulli's formula. We collect the u as pi x, and the dv now is the sine n pi x dx. For the u, we differentiate. U prime equals pi, u double prime equals 0. For the dv, we integrate. Integral of dv is v equals integral of sine n pi x dx is negative 1 over n pi times cosine n pi x. The integral of v is v sub 1 equals negative 1 over n square pi square times sine n pi x. Substituting the values in our Bernoulli's formula, we have the value of b sub n equals this pair of factors is the u times v minus the second pair of factors is the u prime times v sub 1. Then we will evaluate this with respect to the limits from 0 to 1. We have now the two big groups. We're going to simplify some of the terms. Look at this sign and pi. This becomes 0, so we can cancel this group. In the group here, there is a factor of 0. So this group is also cancelled. For the group in here, the sign of n pi times 0 will give sine 0. And sine 0 is also 0, which means we cancel the three big groups. We will have the value of b sub n based on this group only. Let us simplify this further into negative pi over n pi. This cosine n pi times 1 becomes negative 1 raised to power n. We can cancel this pi in the numerator, and there is pi in the denominator. And the final answer is negative of the negative 1 that is raised to n over n. Take note that the negative sign here can be written as negative 1, which means we can combine this negative 1 and this negative 1 that is raised to power n. And that becomes negative 1 raised to n plus 1. This is the value of our b sub n. Let us copy it down here. Let us now substitute the coefficient values in the Fourier series expansion formula. So this formula here, we write like this. A sub 0 is the pi over 2. This is the value of our a sub n. This is the value of our b sub n respectively. But take note that in our a sub n, we said that this is only true when n is odd. To satisfy this, we're going to distribute the summation formula to each of the terms inside the group. So it becomes like this. And for the a sub n, write here the lower limit as n equals 1, 3, 5, and so on, up to n equals infinity. We simplify this complex fraction as pi over 4. Simplifying further, we can move the constant term in here outside the summation symbol. And the constant is the negative 2 over pi. What remains here is the 1 over n squared. This is the final answer.